those. All right. For the first one, Campbell, is it growth or decay? Decay, because that 1/3 is less than 1. What is our domain? Jackson. Negative infinity to infinity. What would be our range, Laurel? Least to greatest. Excellent. Negative infinity to 0, and we'll prove that in a second. Julia, what's our horizontal asymptote? Oh, be careful. Andrew. Y equals 0 is the horizontal asymptote. Remember, if you have that plus or minus, that determines your horizontal asymptote. Okay, plus or minus K value, anything on the outside. Okay, what is our y-intercept, Phoebe? Good, 0, -6. Now, how we get that information is if you started with our table of values, okay, so we have 9, 3, 1, 1/3, and 1/9, okay, that's our original parent function. Then you would multiply by -6. I know some of these points fall off the graph, but you see where the graph is heading. So, -54, -18, -6, -2, -6/9, which you could reduce. So, our horizontal asymptote is y equals 0. Okay, we have 0, -6, 1, 2, 1, -2. Okay, so keep in mind, this is what a decay graph looks like. Okay, and it's just flipping right over the x-axis, and this is what you would get. Hence the range negative infinity to 0. So anytime you have a reflection, you're going to start with negative infinity. And then it leads to your asymptote, which is plus or minus k. Okay? Now for number 2, Rory, growth or decay? Growth. Good. Grace, domain. Good. Range, John. Good. Excellent. Horizontal asymptote, Josh. Number 2. Y equals 2. Must be written as an equation. Our y-intercept, Lizzie, 0, 3. And again, if you were to do your table of values, 1/16, 1/4, 1, 4, and 16, and you're just moving them up 2. So here's your horizontal asymptote. Okay, we have 0, 3 like we were told, 1, 4, now it's 1, 6, so on. Okay, good. Any questions about 1 and 2? Okay. Now we get into word problems. Anytime it says model, okay, if it's asking for an exponential growth or decay model, it's going to be your equation you're working with. Okay, so state the original amount of the car. Gavin, 5,000. Okay, 5,000 is typically that first number. If you want to make sure, t equals 0. Is this equation growth or decay, Mustafa? Why? Okay. 0.624 is less than 1, making it a decay. Okay. Now, state the growth and decay factor, then state the percent. These two are different. Okay. What would be, since it's decay factor. Okay. What would that be? Anybody know? Campbell? It would be the 0.624. Okay, that's the decay factor. Remember, they get that from A equals P times 1 minus R to the T. They already figured this out for you. Okay, 1 minus R is your decay factor, which is inside the parentheses of 0.624. Now for the last question, state the percent. It is not 62%. Yeah, Grace. Okay, more exact. More exact, yeah. 37.6%. Okay, since that is to the thousandths place, okay, 0.624, we're taking 1 minus R equals 0.624. Okay, when we subtract 1, solve for R, you get 0.376, which is for now 37.6%. Okay? Right. So the decay factor or growth factor, decay factor is 1 minus R, which they did for you. Okay? Now number 4, Abigail, original amount. Good. Okay, is this growth or decay, Bianca? It's growth. B is greater than 1, or 1.257 is greater than 1. What is our growth or decay factor, Lindsay? Good. 1.257. And remember, your growth factor is 1 plus R. So what is our percent increase, Emily? Good. Okay. Excellent. Okay. Now we're given 2 equations, and you have to determine if it's growth or decay, domain and range. Okay. All right. For the first one, Lily, growth or decay? Decay. Good, because 1/3 less than 1. What is my domain and range, Tori? Okay. The range, Sam. 4 to infinity. Remember, since there's no reflection, your horizontal asymptote will start off your range. Okay. Now for B, let's see. Campbell, growth or decay? Growth, good. 5/4. Greater than 1. Okay. Domain and range, Laurel. Negative infinity to -1. Excellent. Okay. Horizontal asymptote is -1. Then there is a reflection. You got the same one again with the negative. So sorry about that. Negative infinity to -1 would be your range. Okay. Questions? Then the last one. Okay. Jackson, original price. 24,000. Good. Okay. What is the decay factor, Charlotte? Good. 0.745. Excellent. The percent decrease, Julia. That's the decay factor. (25.5%). Take 1 minus R equals 0.745. Okay, subtract 1, divide by -1. Okay, so for D, this is where you need your calculator. 15,000 equals 24,745 to the T. Okay, the nearest year, which is going to make it a little difficult. Anyone get an answer? Sam? 2 years. If you got 1.6, I think it was 1.6. If you said between 1 and 2 years, 2 years, you're good. Okay? Yep. Okay. In your calculators, if you go into y equals, left-hand side is 15,000. So if you are still struggling with this would be a good point to go through this again. Okay, 15,000. Y2 is 24,000 and 0.745. Yes. Okay, so that's first. Entering it in to Y1, Y2. Now we have to adjust our window. Some of you probably have it for something else. Okay, mine is reset to the standard screen. So I'm going to try doing X min is 0, X max is 10, okay, because that's talking about the years. Scale's fine. Y minimum, you could do two things. You could keep it at 0, okay, so I'll show you what that looks like, because we're talking about money, okay, you keep it at 0. The highest value that we have is the original price of the car, 24,000. And the scale, I could do 100. Okay, this is just one way. Some of you might have had the minimum at 10,000, or you might have it at 5,000 or 14,000. You just want to see the actual line across. So hit graph. And then to find the intersection, second trace, number 5, and enter 3 times. 1.6. Okay? All right. We are going to, got it? Okay. So if you had that, okay, you would just see it right here. Okay. Let's see what happens when we do trace. It might work. Should work. And it will work that way too. If you can't see it, John, for some reason, if it doesn't show that blue line, or the second line, then it's hard to read. So that's why even if you did 14,000 here, it just bumps it up just enough so you could see it. All right. And again, sometimes it works, sometimes it doesn't, depending on the calculator too. It's very temperamental, all these calculators. So just be careful with that. So if you had 1.6 or to the nearest year would be 2 years, you are correct. Okay. Now, what is the value of the car after 20 years? Sam, go ahead. $66.57, you said? Okay, is that reasonable? Okay, so what we did is, what is the value of the car after 20 years? Take your model at the top and plug in 20 for T. Okay? Any questions about the warm-up? Okay. Any questions about the homework? No? Good. All right. Take out your notes. Okay. Just so you know, you do have an exponential test on the 28th. On the 28th. This is page 9, you guys, I think. I didn't check on it. No. Okay, page 9. All right, so today we're going to learn 2 more formulas. Yeah. Yeah. I have an extra one here if you want. It's right up front in the binder. It's just easier that way instead of drawing it out. Yep, that one. Right? Yeah. Okay. All right. So, 2 more formulas. We are looking at compound interest and compounded continuously. Okay. So, the difference between the two, okay, compound interest is the interest paid on the initial investment called the principal and on previously earned interest. So, basically the difference between the two is compound interest is compounded a specific number of times per year. So, for example, quarterly is how many times? 4. Monthly, 12. Okay? So, if you notice that both of these, A, P, R, and T are all the same. However, what is different is N. The number of times compounded per year. So, A is your ending amount. P is your principal or your initial investment, what you deposit. Okay? R is your percent as a decimal. T is your time in years. So that has not changed. But if you notice, with this formula, the N is under the R, so it's R over N. And then it's also in the exponent. Okay? You are only dividing by Rn. It's not 1 plus R over N. Okay, keep that in mind because you'll see that a lot. Then, if you have something called, it's continuously compounded, that's your key word. You will be using the PERT formula. Okay? A, P, R, and T is the same. However, B is just like pi. It's an irrational number that is in your calculator. To find that second ln is one way. Okay. Second ln is below the log key. Okay. Below the log key, right next to the 4. Okay. Second ln, it gives you e with the exponent already. Okay. So e is for the continuous function. All right. So we're going to look at all of these side by side. So for, excuse me, number 1, you deposit $4,000 in an account that pays 2.92% interest. Find the balance after 3 years if the interest is compounded with the given frequency. Okay? So we're trying to find our ending balance. Okay? We're trying to find that in all 3. Okay? What is our initial investment? $4,000. Good. Okay. What is our rate? Written as a decimal, not a percent, as a decimal. Sam. 0.0292. Okay. What is our T value? Well, 3 years. The reason I put these 4 things up there is they're consistent and will be the same for any one of these given frequencies. The frequency will change the problem. So, quarterly is how many times per year? So your N equals 4. Okay. So, using our formula, A equals 4,000 times 1 plus 0.0292 over 4 and 4 times 3. Okay. Since it's a number of times per year, we are using the compound interest formula. Okay. I'm going to show you what it looks like in our calculator. I'm going to show you 2 different ways. Okay. There was actually a third way that came up too. God bless you. Okay. The first way is step by step. If you do not want to worry about parentheses, some of you may not, you take care of your fraction first. So 0.0292 divided by 4 first, then add 1, second step, then raise it to the exponent. What's 4 times 3? 12, brilliant. And then you multiply that by 4,000. That's the long drawn out way, however, the accurate way, okay? If you do not want to worry about parentheses, okay? So your ending balance after 3 years, compounded quarterly, is $4,364.82. So just jot that down. This is what it would look like with parentheses, okay? Especially for some of the older calculators. 4,000, parentheses, 1 plus another set of parentheses, 0.0292 divided by 4, close it, raise it to the 12th. Now, I'm used to doing this many parentheses because of some of the different versions of calculators I've seen and used, okay? But when you hit enter, you end up with the same result. But it did come up in one of my other classes that you would not need parentheses around the fraction, and you'll still get the same answer. I'm a little worried about that because certain calculators won't calculate the same thing or just happen to calculate it that way for this particular problem, okay? So it's totally up to you which way, doesn't matter. As long as if you're confident with the parentheses around things, then go ahead, okay? If you need to jot it down near your notes, do that as well so you don't forget, okay? Those of you with the older calculators that actually show the caret there, okay, the actual exponent piece, you will need parentheses around 4 times 3 or whatever number times the year, okay, if you can't calculate it off the top of your head, okay? So just keep in mind, little things like that with calculators will come up. All right, what will change for weekly? Yeah. The n, which would be what? 52. Good. Excellent. Let me just jot this down. Okay. So what would change is your n would equal 52. So a equals okay. What did we end up getting? Sam? What was it? Way too much. Be careful. Laura? 0.10. Sam, I would love to have whatever bank you're working with, my friend. Do you see what you did? Did you do that? I don't know. I don't even know.
Oh. Yeah, instead of putting dividing it by 52, I just put a special word.
And had 52 here. Oh, all right. I would like that miscalculation in my bank account, please. Okay, good. So again, not much difference, okay, with it. So Quarterly and weekly, those are some keywords you will hear to use compound interest, as well as semi-annually, as well as annually, daily, monthly. Those are some keywords to use this formula, okay? What is automatic is continuously. Will we still use this one or the second one? Will we use compound interest or the PERT formula? PERT, right? Okay. So, we have A equals 4,000 E 0.0292 times 3. And I'll walk you through that as well. Okay. Okay, we have 4,000. Second ln, which is right next to the 4. 0.0292, and I like using that E because it does the exponent for me. I don't have to do anything different or another step. This is what you get. Okay, and it's only the rate times time. Rate times time. There's no N for this one. Okay? E second ln. Okay? Is one way. The E is also here, but I like this one because it gives you the exponent. Okay? Put that down. Okay? So, just the next one we are going to set it up, but we'll get to it after lunch. Okay? Two separate things going on here. How long will it take to double your money if you invest it at a rate of 6% compounded semi-annually? What if it's compounded daily? Okay. What did they not give us? Yeah. The amount of money you originally have. So what is the smallest dollar amount we could deposit? One, right? $1. Okay. So if we were to deposit $1, our ending amount would be what? $2. Okay? What is our rate as a decimal? Good. Do we know the time? No, that's what we need to find out. Okay? So, the first question is semi-annually. So what is your N going to look like? 2. Okay? So just to set up, and then we'll get to this after, 2 equals 1, because our ending amount times our beginning, or equals our beginning, 1 plus 0.06 times 2, 2t. Okay. Now looking how we have it set up, how do we find t? What did we do in all the others to find t? Yes, Sam? Y1, Y2. We will get to that when we get back. Okay? You guys have a good lunch, okay? Before lunch, we left off at setting these problems up in terms of how long will it take. We're always looking for the time. Anytime it's saying how long. Okay. So we have 2, and if they don't give you any dollar amount, $1 is always your principal that you start with. If it says triple your money, this would be $3. It's just easier to deal with. So in our calculators, we're going to start y equals as 2, and 1, parentheses, 1 plus, point, divided by 2, raise it to the 2x. So, some of you will probably still have the window set as is. I'm going to do 0, 10, and then 0.5 is $1 because we're talking about $1 and $2 amounts, and then hit graph. Okay, so if you did 0 to 10, this is roughly what you would see. Okay, do we see an intersection? No. Since we don't see the intersection, your second trace, number 5 intersect, you'll get an error message, no sign change. So what do we have to adjust in this case? Yeah, Andrew. The X max. So let's bump that guy up to 20. And now graph. Okay. Now that we see the intersection, we could do second trace, number 5, enter 3 times. So it will take about 11.7 years, or about 2 years, 11.7, it says round your answers to the nearest tenth. So 11.7 years to double our money, okay, if we're compounding semi-annually. So your T, 11.7 years. So if we look at the second question, what if it's compounded daily? What are we changing? Yeah, Andrew. The end value. We're going to change the end value to T. You guys do that one out and let me know what you get. You could keep the window just as is. Yeah. Mm-hmm. You won't see anything like that now. It's just an extra day. Yeah, let's. Mhm. Uh-huh. So, well, not the one in front. So let's go back. Let me just show you. This is what I have. I'm going to change this now to 365 and change the 2 to 365x. In the graph. Okay. What do we notice? Sam, question? Really similar, right? 11.6, I think it was. 11.6. Really, really similar, okay, to double your money. So, some cases, some of you might have saw that and be like, that doesn't seem right. You know, and so, like it should be less than that. How many of you thought less? It would be less time. Okay? If you say that, you're okay. You're on the right path. Interest, it's really strange. It's a complicated whole subject to really grasp and understand. So, looking at the two formulas for semi-annually as opposed to daily, okay, it doesn't change much. Okay, it doesn't change very much. You have 11.6 as opposed to 11.7. So a lot of these you're going to see, just like in the first problem, even though the times per year changed, the amount didn't change that much. Okay, and that's true about anything. Unless you have something wrong with the formula, then you're going to see a big difference. All right? Any questions about those that we just did? All right. I want you to look at number 4. Read it through, and then tell me what formula we're using and what we are solving for. Okay? So read number 4 through. What formula we're using and what are we solving for? Okay, I'll give you a minute. All right. What formula are we using? Jack? Good. The PERT formula. Okay, we are using the PERT formula because it says continuously. What are we solving for? Go ahead, John. The initial investment, so the principal. We're finding that p-value. So 40,000 e to the 0.035 times 10. Okay. How would you go about solving? How would you solve for p? What do you guys think? What's your first thing you would do? No right or wrong, it's just a discussion.
Divide 40,000 by
Perfect. Okay. So to get p by itself, you would divide e to the 0.035 times 10 on both sides. Okay. So, show you again 2 ways. The first way, we could literally do what we had on the board. 40,000 divided by parentheses e to the 0.035 times 10. Okay. Or if you wanted to do e, okay, you get this amount. In our calculators, these calculators that are very similar to mine that I have on here, you could literally copy and paste this answer, okay, by doing second negative sign, enter, okay. However, the principal, one thing about principal, okay, does anyone know what our initial amount should be? This is it, but would it be $28,187.52 or 53 cents? It's a slight difference, very slight. For the principal, you would round up to 53. Even though it doesn't look much like rounding in general, I want you to try that out. Do it in your calculators right now. $28,187.52 e to the 0.035 times 10. Tell me what you get. Okay, our goal is to look for 40,000. Seems pretty close, right? Okay. Now do. I would take either or, because it's hard to remember all these rules. Is that more accurate? Yeah. Okay. Either one would be acceptable. Yeah. It worked too? Interesting. That's a new way. That's a new way, Sam. That's good. Good job. Okay. Well, Sam did another way that I will look into too, but it definitely does work. Yeah, Grace. All right, I'll check yours out in 1 second. Okay. What Sam did, he took this equation and did 40,000 for Y1, put X in for P times E to this, and adjusted the window accordingly, right? And he found what X equals as well. Okay, so again, another way. But solving is, you guys know how to solve algebraically as well. All right, so I want you to try 2 on your own right now. Number 3 and number 5. Okay, number 3 and number 5. All right, let's look at number 3. Okay. You deposit $1,500 in a bank account that pays 3% interest compounded monthly. So we're using the first formula in terms of compound interest. Find the number of years it takes your balance to exceed 2,500. Round your answer to the nearest 10. What did we get? Andrew? About 17 years. How many of you did get that? Not a lot of hands. Did. Get about 17 years. Why not a lot of hands? What, John? Yep. Okay. So X-min, X-max. If you had the X-max at 10, you're not going to see the full window. Okay? So this would be 20 because you're talking about time. Okay? So your X value should be pretty straightforward. Either 0 to 10, 0 to 20, 0 to 50, whatever you want just to see how many years. Your Y-min is where it gets a little tricky, okay, to think. Think about dollar amounts. Lowest dollar amount you could have is 0, hopefully. Okay. Y-max, looking at these two values, okay, your initial and your ending, this is smaller than this, right? So we know it's increasing. So if we just put in 2,500, we are going to see a horizontal line at the top, right? If we keep it as Y max at 2,500, which you can, okay? But again, some calculators are very temperamental. I want to go slightly above that. So I could do 3,000 to look, okay? By that way, when you're graphing the two, you're going to have your XY be like this. And you see the two graphs, okay? So it's understanding what you want to see, right? So, and I guarantee a bunch of other people have the same question as well. So looking at the X-min and max, that's talking about your time. That is looking along the x-axis, okay? If you cannot see the intersection, it won't give it to you, all right? Most of the time, you will be set with the Y values. It's your X that you have to adjust. Your Y min and max come from your values here. Your starting and your ending, okay? If you want to, and it's hard to even put specific numbers that are set to do besides negative a million to a positive a million, because we've seen X and Y values that are higher than that, okay? So there's no set for Y min and max. We have to start thinking of what values are given to me, what do I want to see in that window, okay? It just takes some practice and getting used to, all right? So this ends up being approximately 17 years, okay? All right? Then you have Bank A and Bank B, okay? Bank A is at 4% compounded quarterly. Bank B is 4.15% compounded annually, okay? What did we get for Bank A? Grace? So for Bank A, this is what we should have gotten. How much interest did you make with Bank A? Andrew? Yeah. Okay, good. Now Bank B is compounded annually, but at a 4.15%. What did we get for Bank B? Sam? Good. And how much interest did we gain in Bank B? $5,017. Okay. So clearly, Bank B, we make more money, right? How much more interest did we make with Bank B as opposed to Bank A? So how much more interest did we make? Yeah. Good. 128. More interest. That's how much more we made. Okay. Questions? Okay. There's one last one we're going to do together before I give you your practice. Number 6. Okay, read it through. Tell me what formula we're using and what are we trying to solve. I just answered that last one. Andrew, pick a card. Okay, what we got? Okay. Gavin, what formula are we using? Okay, so compound interest. Okay? Sam, pick a card. Pick one. What do we got? Okay. Finn, what are we solving for? Interest rate. Okay. So we have 3,000 equals 670. 1 plus R. 1, 3 times 1. Okay. So this ends up being typically what you guys are going to see anyway with annually. Okay. We would always have to find the rate. We would not have to find the end value. Okay. So from here, we have 3,000 equals 1 plus R cubed. How do I go about solving? What do I do first? Kevin, please pick a card. Thank you. Emily, what do I do first to solve for R? Not sure? Ken? Julia? We want to solve for R. You have to do something before that. Boop, boop. We got Andrew. Woo. You are correct. Okay. You would divide both sides first by 2670. Okay, so you could do this in your calculator. 3,000 divided by 2670. Leave that in your calculator. Okay. What we got? Abigail, then what do we do? Okay. And once we find that in our calculator, we take the cube root. If you can't find the cube root, what do you raise it to? Yeah, Laura. 1/3. All right. So we have 3,000 divided by 70. And then raise it to the 1/3. Then what do we do? Subtract 1. So our rate, okay, is this right now, but for percentage, multiply by 100, and you get 3.96 or 4%, depending on what it said to round to, okay? 4% or 3.96%, depending on rounding. If you were to round this to like the thousands place or the hundreds place, eventually you still would get roughly 4%. Okay, so any questions about finding A, P, R, or T? Yeah.
When they give you like the A value and like the other information,
Yeah.
you can like, does it matter or can you always just plug it in like the Y and it will still be?
For what? What do you mean?
Like for this problem, for example, you're able to plug it into Y equals what it could do this here.
The rate, no. And I looked what Sam did before with the X for the in front of the E. How did you adjust your window? For X though? For X you made it big? Okay. Because I did it the same way just to see, and you would really have to adjust your X value. Pretty large for that one to work. So for here, it would take some trial and error, but I think your best bet is just to solve it algebraically. Okay? Because it's, again, dealing with more windows you want to adjust. All right? So your homework is in your blue or yellow packet. Okay, the 5.6 practice, 2 and 4, 5.7, 6, 7. Okay, so in your practice, I forget what page is. This might be page 4, I think. And then this might be page 6 and 7, I think, the last 2 pages. Okay, so this is in your blue or yellow packet. This was from last class's lesson. This was on 5.6, and this is today. Okay? All right. Get started on those, or...